Have you ever wondered what would happen if your brain could keep living after your body stopped working? Imagine your brain, all alone in a safe tank, still receiving the oxygen and nutrients it needs, while your body is nowhere to be seen. Would you still feel like yourself? Would you even be aware? Welcome to Van Duel Theories, where we explore big questions about science, life, and the future. Today we're asking a very strange but fascinating question. Can the human brain survive without a body? It might sound like something out of a science fiction story, but it's a topic that many scientists and thinkers are exploring. If you enjoy diving into mysteries like this, please like this video and subscribe so you can join our growing community. Now let's get started. First, let's look at what the brain needs to keep functioning. Our brains can't just float around by themselves. They require three main things. Oxygen, essential for energy and cell survival. Nutrients, such as sugars and other chemicals that provide fuel. Waste removal, to clear out toxins and keep cells healthy. Inside our bodies, our blood does all this work. The heart pumps oxygen-rich blood from the lungs and delivers nutrients from our food right to our brain. It also picks up waste products and carries them away. It's a very efficient system. Now, if you take the brain out of the body, you have to replace that entire system on your own. Imagine building a mini life support unit, a system of tubes and pumps that delivers oxygen and nutrients while also filtering out waste. It's like setting up a perfect environment for a delicate plant, except the plant here is your brain. Scientists have done experiments with animal brains, starting with frogs and mice, to see if they can keep them active outside the body. In some of these early tests, researchers managed to keep basic cell functions going for a little while. More recently, experiments have shown that it's possible to keep certain brain cells alive and working for a few hours. But remember, keeping cells alive is very different from keeping a brain conscious or fully aware. It's important to understand that the brain's survival depends on maintaining very precise conditions: the right temperature, constant oxygen flow, and balanced nutrients. If anything is off, the brain cells quickly begin to die. That's why, even in experiments, the window for keeping a brain alive is very short. Now let's talk about a couple of ways people have tried to preserve brains. One popular idea is cryonics, freezing a brain, or an entire body, at extremely low temperatures. The hope behind cryonics is that one day technology will be advanced enough to thaw the brain and repair any damage, almost like restarting a computer. While this idea is very experimental and no one has yet been revived from a frozen state, it shows how far some researchers are willing to go to preserve life. Another method is using special chemicals to prevent the brain from decaying, a bit like how museums preserve ancient specimens. This process stops the brain from rotting, but it doesn't keep the brain running in a normal, active state. Instead, it essentially puts the brain on hold until, in theory, future science can bring it back to life. The ultimate dream for some scientists is whole brain emulation. That means scanning every detail of the brain and recreating its functions in a computer system. In this scenario, your thoughts, memories, and personality could, in theory, be preserved digitally, even if your body is gone. But that idea is still firmly in the realm of science fiction. Right now, these preservation techniques are more about keeping the brain from decomposing rather than keeping it alive in the full sense of the word. To have a brain that's truly active, thinking, feeling, and aware, we'd need a system that continuously provides all the necessary resources: oxygen, nutrients, and waste removal. That's a huge challenge, and we're not quite there yet. Here comes the big question. If we manage to keep a human brain alive outside the body, what would it experience? Our brains are used to getting constant signals from our eyes, ears, skin, and other senses. These signals help us understand the world and feel emotions. Without them, a brain might be in a very different state of awareness. If a brain is floating in a lab with no sensory input, it might not be able to generate normal thoughts or feelings. It could, in theory, slip into a kind of coma or a state similar to being in a very deep sleep. Maybe even like a continuous daydream where nothing much happens. Alternatively, scientists have imagined that we could create artificial signals to feed into the brain. That way, the brain might see or hear things, even though it's not connected to a body. For example, If we send light signals directly to the brain's visual areas, it might be tricked into believing it's watching a beautiful sunrise or a fun cartoon. But this technology is still very far away from what we need to truly mimic all the sensations of having a body. Let's be clear, even if we could send these artificial signals, it's uncertain whether the brain would feel exactly the same as it does inside a body. Our emotional experiences are deeply linked to the physical sensations provided by hormones and touch. Without those, the quality of experience might be very different from what we consider normal life. In short, while a disembodied brain might technically be able to remain active, it's very unclear what its inner life would be like. Would it simply drift in a silent, isolated state? Or could we create a virtual world so real that it could still enjoy, learn, and even laugh? These are questions that remain open and deeply fascinating. When you hear about brains surviving outside the body, you might think of movies or books where mad scientists keep heads in jars or characters live in digital worlds. These ideas have been popular in science fiction for many years. They let us imagine a future where the mind can exist separately from the body. But how close are we to that reality? Today, scientists have managed to keep animal brain cells alive for short periods under very controlled conditions. We have also seen early tests where isolated brain tissue shows some activity. However, a fully functioning human brain, actively aware and experiencing life without a body, is still far beyond our reach. There are many challenges: maintaining the delicate balance of oxygen and nutrients, preventing infections, and ensuring the brain doesn't shut down due to lack of sensory input. Even if we solve the technical issues, we must also confront some very important ethical questions. For instance, is it kind or humane to keep a brain alive if it might suffer from isolation or lack of normal stimulation? This is where the line between science fiction and science fact starts to blur. Every breakthrough in technology pushes us a little closer to possibilities that were once only imagined in stories. But each step also forces us to ask deeper questions about what it really means to be alive. Now we reach the heart of the matter. Should we even try to keep a human brain alive without a body? Even if we can do it, there are many ethical and personal questions that need to be answered. First, consider psychological well-being. If a brain is kept in a tank without a body, it might be completely isolated. No physical touch, no sounds, no smells, nothing to remind it of a real life. This could be very harmful to its sense of self. Imagine feeling completely cut off from the world for an indefinite period. Next, think about hormones and emotions. Our feelings are not just in our heads, they come from the body too. Chemicals like dopamine, serotonin, and adrenaline help us feel happy, excited, or even scared. When someone takes medicine for a condition like ADHD, their mood and behavior can change dramatically because of these chemicals. Now, if we remove the brain from the body, we also remove these natural hormones. Even if we try to replace them with artificial solutions, it's hard to know if the brain would feel the same. Would it still experience joy, love, or even sadness in the same way? Then there's the question of identity. Are we simply our brains, or does our body play an essential role in who we are? Without the physical sensations of being in a body, like the warmth of a hug or the rush of a good workout, would you still feel like the same person? Some argue that the brain is the seat of our identity, while others believe that our full human experience comes from the complex interaction between the brain, body, and our environment. Finally, we must ask, what if the brain doesn't want this existence? If a brain in a tank could feel discomfort or pain from isolation, should it have the right to request an end to its own suffering? And how do we even begin to define quality of life for a being that exists only as a brain? These questions remind us that even if the technology were available, we'd need to think very carefully about the moral and personal implications of such a breakthrough. So, what does all this mean for the future? Right now, the idea of a fully conscious, disembodied human brain is still mostly science fiction. In the lab, scientists can keep brain cells active for a short time, but we're far from a scenario where a brain could live a full life on its own. However, research is moving quickly. Advances in brain-machine interfaces and tissue engineering are opening new doors. It's possible that one day we might have the tools to repair or even support brain function in entirely new ways. But if that day comes, we'll also need to answer important questions about what it means to be human. We might face a future where saving a brain becomes an option for those who are very sick or injured. But then we must also ask, is it really a win if we save the brain, but lose the full human experience that comes from having a body, emotions, and a complete sensory world? Even if these technologies become a reality, it is essential to think about how we use them and whether they truly benefit us as human beings. To sum it all up, can the human brain survive without a body? From what we know, it is possible, at least for a short time and under very controlled conditions. However, keeping a brain truly alive in the way we experience life is a far more complicated challenge. It isn't just about staying biologically active. It's about maintaining consciousness, emotion, and a sense of identity. And even if we can achieve that one day, we're left with many ethical and personal questions. Would such a state be humane? Would it preserve the true essence of who we are? Or would it turn us into something less than fully human? I'd love to hear your thoughts on this fascinating subject. Do you think it's a breakthrough we should pursue, or is it a line we shouldn't cross? Let me know in the comments below. If you enjoyed this exploration into the mysteries of the brain and the future of human life, please like this video, subscribe for more content, and share it with anyone who loves a good scientific mystery. Thanks for watching Van Duel Theories, and until next time, keep asking the big questions and stay curious.